So we're asked to make a sketch of this graph by getting three ordered pairs. So let's make an x and y table. We'll plug in a number for x and see what it spits out for y. So usually starting point is we try to plug in 0. And if you do 0 minus 2, you get negative 2. So what power do you need to raise 3 to be to make it equal negative 2? Well, that's impossible, because you can't change the sign of a positive number by raising it to an exponent. It can't go from positive 3 to negative something. So that's out of the picture. Let's try plugging in 2. And if you plug in 2, 2 minus 2 gives you 0. So what power do you need to raise 3 to be to make it be 0? That's what a logarithm asks us. What power do you need to raise the base to be to make it be this piece right here? There's no way to change 3 to make it be 0 with an exponent. You can't plug in a number for an exponent to make 3 equal 0. So that's out. So how about let's try 5. 5 minus 2 gives us 3. And what power do you need to raise 3 to make it equal 3? That's just 1. Another nice and easy one is if you plug in 3 in for x. Because plugging in 3 in here, 3 minus 2 gives you 1. So what power do you need to raise 3 to be to make it equal 1? That's 0. If you raise 3 to the 0 power, it equals 1. So we said we needed 3 ordered pairs. We got to go find another one. And the way I'm getting these numbers is I'm thinking about squares of 3. Like 3 to the 0, or powers of 3, I guess. 3 to the 0 makes 1. 3 to the first makes 3. And now and so that's why I chose 5, because 5 minus 2 would make 3 in that parentheses. So I could do 3 squared, that would make 9. So what number do I need to plug in here to get 9 out for the function? That's the answer. That's 11. If I plug in 11 in for x, 11 minus 2 gives me 9, and 3 to the second power would make us be 9. So 11, we said that's the second power. That would answer that logarithm. And if you're really having trouble with where I got those numbers from, just make sure to go check out a video on the basics of logarithms. But yeah, check out that video, and that's all I'm doing there is I'm using what a logarithm is to find out those points. And now that we have 3 dots, we can graph them. 5, 1, 1, 2, 3, 4, 5, 1. There's a dot right there. At 3, 0, we have a dot. And 11, 2, we have a dot. So somewhere way out here, it's getting bigger at a slower rate. So this is going to be a sketch of the graph here in red. Because back here where we plugged in 2, we got 3. It was what power do you need to raise 3 to be to make it equal 0? That was impossible. So we knew the graph could not be where x equals 2. Likewise, x equals 0 was out of the picture, so I drew a vertical asymptote right here. And then I just made my graph sort of cross the points. That's pretty bad. Let's see, I can't move it. The red line's supposed to go through those points, but you get the idea. It increases at a slower and slower rate as we go on the x-axis. Now we can answer their question about the domain and range. Domain of this function is all the values you can plug in for x. And we found a couple when we were plugging some in. We said 0 does not work. We said 2 does not work. But anything a little bit bigger than 2 would get us a real answer. So we're going to go from least to greatest. 2 is the least number you can plug in for x. Infinity is the greatest number you can plug in for x. Now we're ready to answer a question on range. Range is all the y values that can come out. So does this graph have a place where it stops getting low, or does it keep going? The answer is the arrow tells us it keeps going down and down and down. So we're going to say negative infinity is as low as you can go. Positive infinity is as high as you can go.